Hi, welcome back to my class. I'm Homnath Panta, and today I'm going to be talking about the annual percentage rate and the effective annual rate. So this is going to be a short class. In this class, I'll define the annual percentage rate and the effective annual rate, talk about how to compute effective annual rate, and the application of the effective annual rate. After watching this lecture video, you should be able to know what is meant by the effective annual rate and its importance, know the difference between the annual percentage rate, which is APR, and the effective annual rate, compute the effective annual rate, and apply the effective annual rate in solving the time value of money problems. Okay, these are the main objectives I would like to achieve in this class. So let's start with annual percentage rate. So what is the annual percentage rate? So basically, the annual percentage rate is the stated rate in contracts, or it is a quoted rate by banks and brokers. It is also called the nominal interest rate. Okay, so in time value of money, a lot of times you'll see a discount rate, interest rate, bank pays 10%, things like that. Okay, so all the rates are given in APR. Okay, for example, 10% annual rate, 10% semi-annual rate, 10% quarterly rate, and 10 annual rate with monthly compounding. Okay, so these are different things. So if you are talking about 10% APR annual and 10% APR monthly compounding, they are not going to be the same. Okay, so because if you have 10% APR compounding monthly means every month interest is going to make interest. Whereas if you have 10% APR compounding annually, your interest is going to start making interest at the end of the first year. Okay, so these are different things. Okay, so we need to know how to convert this APR to effective annual rate. Okay, so what is the effective annual rate? The effective annual rate can be denoted as EAR or EFF. Okay, so effective annual rate is the rate after considering the effect of multi-period compounding. Okay, so if you have more than one compounding, that means if your interest is making interest more than one time a year, then your effective annual rate and your APR, they're going to be different. Okay, for example, 10% APR compounding monthly is 10.47%. And in next slide, I will show you this effective annual rate. Okay, so to summarize here, effective annual rate is the rate of return after considering the effect of compounding. Okay, so how to compute effective annual rate? Let's look this example. Find the effective annual rate of 10% annual percentage rate compounding monthly. Okay, so 10% APR, that means end of the first month, your interest is going to start making interest. Okay, so the 10% APR compounding annually and 10% APR compounding monthly, they are different things. We can compute APR, effective APR using financial calculator, using Excel. So let me start with formula. So EFF, which is effective annual rate or EAR, equals to 1 plus APR or 1 plus nominal rate. So this APR is nominal rate divided by number of compounding. Okay, M here represents So this compounding equals to 12 in this case because it's monthly. This M is not M equals to month. This M represents here compounding, number of compounding. If annual compounding M equals to 1, so 10% equals to 10%. Okay, but if this compounding is more than 1, then APR annual rate, they're going to be different. Okay, so equals to 2 if compounding equals to semi-annual. This M equals to going to be 4 if it's quarterly compounding. M equals to 12 if it is monthly compounding. M equals to 365 if it is daily compounding. Okay, so 1 plus nominal rate divided by number of compounding, and then the whole thing raised to number of compounding minus 1 is going to give you the effective annual rate. So in our example here we have 10% nominal rate, so 1 plus 10% divided by 12, and then whole thing raised to 12 minus 1 is going to be 10.47 equals to 10.47%. Okay, so you can use this formula to compute effective annual rate. So now difference between effective annual rate and APR. APR is 10%, but effective APR is 10.47. Now let's use financial calculator in Excel to solve this problem. Okay, so here is the example, the same example. I'm using this financial calculator, okay, to solve this problem. So if you are using TIBA2 plus financial calculator, so first you press second, okay, and you press number 2, which gives you icon, okay. Icon means interest conversion. Then you will see NOM. NOM stands for nominal rate or APR. So in our example, this nominal rate is 10%. So put 10, okay, and enter, and press arrow up, arrow key, and then you define your number of compounding. C by Y is compounding per year. Since this is monthly compounding, we have 12 compounding a year. If C is semi-annual compounding, you can put here 2. If it's daily compounding, you're going to be putting 365. But in our case, it's monthly compounding. So C by Y equals to 12. And you enter, go up key, and then you'll see EFF. And the screen will tell you CPT, compute. So press compute. Your calculator will show you 10.47. Okay, so basically using calculator you can get 10.47%. Okay, so this is effective annual rate. Now let's use Excel. How can you find out the effective annual rate using Excel? Okay, in Excel you can use effect function. Okay, so I'll show you how to do that. So I'm just waiting for the Excel here. Okay, so first summarize the problem here. So APR equals to 2% and your M, which is compounding. So we want to find out effective annual rate. So start with, so let me delete that, this one here. Okay, so start with equal and EFFECT. Okay, so effect parenthesis. Now nominal rate, which is APR 10%, and comma, and NPERY. That means number of compounding here in this case. So select that number of compounding. Okay, close the parenthesis, and it's going to give you 10.47%. So if you have not formatted this one as decimal, percentage is going to give you 0.1047. Okay, then you can convert that to percentages by clicking here in the percentage sign. Okay, So this is how you're going to be using Excel. It's pretty easy to use Excel in finding annual percentage effective annual rate. Okay, so now you know how to compute effective annual rate. Now you know what your APR to effective annual rate. Okay, so now let's do some application. So let's apply our knowledge. Let's look this first example here. If you wish to accumulate $140,000 in 9 years, how much must you deposit today in an account that pays an annual percentage rate of 10%? Okay, so this is a time value of money problem. So it's basically asking you what is the present value of if you have $140,000 in 9 years and if the bank pays you 10% APR compounding annually. Okay, and we are using 5 keys in your financial calculator. Okay, so your n is going to be 9 here. Okay, so you put 9 and press n, then your is 10% and press I by Y, and your payment is, in this case there is no payment, it's not annuity. Okay, so there is only one cash flow, so payment in this case equals to 0, and future value is this amount you want to have in 9 years from now, so $140,000. Okay, so put 140 and press F, which is future value, and then you want to find out present value, so press compute and then present value is going to give you $59,373.67. You will see the negative. That does not mean this is a negative number. So the calculator just follows cash outflow convention. That's why this is cash outflow. You are depositing in the bank. So if this is, but it's not, you are not depositing negative 59,000. You are depositing negative positive $59,000 in your bank account. Okay, so this is in this case we don't have any problem. We don't have to know effective annual rate because this problem here has only one compounding annual, so we worry about effective and API because they are same. Okay, in time value of money problems you have to match n, I by Y, and payment. In this case we don't have any problem. Okay, let's look the second example. If you wish to accumulate $140,000 in 9 years, how much must you deposit today in an account that pays an annual interest rate of 10% compounding monthly? Okay, now a little bit complication here. Now your rate is monthly compounding. Okay, so in this case, you have to either find effect or convert all this by Y and payment in monthly frequency. Okay, so in this case you can multiply 9 years by 12 months, so definitely you can convert your n. You can change your I by Y. I by Y is APR. Okay, so basically divided by 12 is going to be 0.8333%. Okay, so you can do that, and since the payment is 0, you can divide 0 by 12, so you're going to have 0. So basically this and this, they are matching here in this case. This is one way to match. Okay, so you can solve this one and compute present value. You get little bit less amount because you have higher compounding. Okay, so that means your interest start making interest, so you don't have to deposit 59,000. You can deposit a little bit less, so still you can keep your goal of $140,000 in 9 years. So basically I'm converting n to month. Okay, it's number of periods, it's a rate per period, and this is payment per period. So since it's 0, does not matter, so you can convert that. Another way of solving this problem is just convert this, just leave that N9, leave that payment 0 because it's 0 means 0, and convert this rate to effective rate. Okay, so if you convert 10% to monthly compounding, it's going to be 10.47. So you can put that 10.47 here, 9 here, compute PV still is $57,000. Okay, so again, there is no problem. You don't have to convert your APR to effective APR here. If you want to, you can do that here, but you don't have to because you can convert N to year to monthly. Now N equals to number of periods. I by Y is rate per period. This 0 is payment per period. Okay, so that's not a problem. Now let's look this example, another example. If you wish to accumulate the same amount of money in 9 years, okay, and you want to deposit in your bank account at the end of each year for next 9 years, okay, and then bank pays you 10% APR compounding monthly in your account, okay, so how much should you deposit each year? You are depositing at the end of the year, okay. Now there is a problem. You have year here, you have year 9 years, you have 10% APR, okay, so you can multiply year by compounding and make number of periods, and you can divide your rate by 12 and get the rate per period. But the problem here is it says you're gonna deposit at the end of each year, okay, so your payment must be annual, because the problem says is annual payment. Annual payment and monthly payment are different. So in this case, you have to have this payment annual, okay. So there is no way you can convert that payment to month. Since you cannot convert payments to monthly, then you cannot convert your N to number of periods, okay. So your N must be matching with your payment. Payment is annual, so your N also should be annual, and your rate also must be annual. So these three things must match, okay. N, I by Y, and PMT, they must match. Otherwise, wrong results. So only way to match these three things is to convert your rate to effective rate. So in this case, you must know how to convert your annual percentage rate to effective annual rate. So this is very important in time value of money. Okay, you need to know how to convert APR to effective annual rate. Sometimes, for example, this case, you can just divide by number of compounding and solve the problem. If it's a lump sum payments and you are talking about present value and future value. If it's a monthly payment, it's not a problem again. But in this case, you have payment is annual. Okay, so it's annual payment. So you cannot convert this N and I by Y to monthly. Okay, you must convert your interest rate to effective annual rate to solve this problem. So hope this lecture video is helping you to understand the importance of understanding the effect of the use of effective annual rate in time value of money concept. Okay, thank you for watching this lecture video, and see you in my next class.